Okay, we'll get started with the next session. So my talk this afternoon is going to be about serverless iPaaS in Azure. Now when we say iPaaS, what we mean by that is integration platform as a service. So we're talking about those specific Azure services that have to do with integration capability. And integration is particularly what I'm interested in because I'm an integration specialist. I'm actually an integration architect. So I'm an MVP for Azure and an MCSE, but I'm also a principal consultant for Mexia. So Mexia, we're enterprise integration specialists. We are a Microsoft Gold partner. And in fact, we're very proud. Last year, we were selected as the Australia Microsoft Partner of the Year, which we're pretty chuffed about. But even prouder than that, I think, is the fact that for the last 2 years, we've placed in the top 10 for the great places to work in Australia. And we have a fantastic team of people that really get along really well. We have a very strict recruitment policy that's very much based on culture fit. We find that even if you're an absolute gun at what you do, if you're not the right sort of personality or fit that can work with the team, then it actually decreases your ability to be effective in our organization. So we have our own internal recruiter. We call her a unicorn whisperer. And what we've done is assembled a team where not only do we work well together, we get along really well together, and that just the combined skills and the ability to work together makes for a fantastic outcome. So we integrate not only technically, but also as people. And since I'm doing such a good job of selling Mexia, if anybody here is looking for a new adventure and you think you might be a unicorn that could fit our team and our skill set, please get in touch with us. Even if we don't have a role for you right now, we tend to get big projects that come on, and then suddenly we have to build up and resource them. So it's always great to know who's out there and who we can contact. So if you're interested, please talk to me, or if you want, you can also look at the careers page on the Mexia website. We'd love to hear from you. Oh, I also want to give a bit of acknowledgement to my colleague Paco de la Cruz, who is a senior consultant in Mexia as well. Quite a number of the slides in this deck are slides that he put together for his presentation at the Integration Bootcamp in Melbourne last month. So generally the slides that look really, really slick and are nice are probably Paco's, and the ones that look very average are probably mine. So I wanted to start by talking a little bit about the concept of serverless and how we got there. So from a historical perspective, if about 10 years ago, if you wanted to build a data center, you tended to build that on premises somewhere, and you had to go out and you had to buy hardware and you had to set it up and install all the software and put your networking in place and all of your redundancy, build a server room if you needed to have the temperatures down and all that stuff. And that was great in the sense that you were in absolute control of your environment, and everybody felt very secure about their data because it was all contained within their walls. But it was a tremendous overhead in terms of management. So when IaaS came along, that was infrastructure as a service. It was basically a concept of rent a server in the cloud. And that took away a lot of the problems, because you didn't have to worry about going out and buying hardware or setting up that hardware. You literally, if you needed to scale up or scale out, you just basically clicked a few buttons, and 10 minutes later you've got hardware running in the cloud. And you didn't have to worry about things like redundancy, because Microsoft took care of that by replicating every one of your VMs at least twice. Even more, you can even do geographic replication, which is much harder to do when you're talking about on-prem. So that was really good, but you still had to look after those servers in terms of making sure that it was the OS that you wanted, making sure that you spec'd them the way you needed to, the right amount of memory and processing power, and you had to install all the software and everything yourself on those. So it was still a fair amount of management. So when PaaS came along, this is essentially renting a platform, not just a server. So in this case, it's like I just want somewhere to host my website, or I want a SQL server that I can put my database on and run it there. But I don't really want to have to worry about setting up the servers or patching them or anything like that. So platform as a service is what gives you that capability. So basically with SQL Azure or with app services, you don't really have to think so much about provisioning the operating system or patching the servers. Microsoft takes care of all of that for you. That said, you still have to worry about things like scalability, right? So when you choose an app service plan, you have to give a right size. You have to think about how much memory do I need, how much processing power, how many instances do I need to have running, and what am I going to do to scale up or scale down as my traffic needs increase or decrease. So you might, auto scaling certainly helps with that, but you have to really get those settings right, don't you? And think about that. So you've abstracted a lot of stuff away, but you still have a bit of responsibility to things at the infrastructure level. So the final phase now that we've got to is serverless, where you really don't worry about anything to do with the servers. All you are concentrating on is your application. That's all you want, is just to be able to run your application and not even think about how it's running or on what hardware it's running on. So the benefits of serverless, of course, is that concept of servers fully abstracted away from you. Your developers can build their applications a lot faster because all they have to worry about is the code and the architecture of the solution. They don't have to think about things like how it's going to scale and all, because scaling will happen automatically for you just by the amount of demand that there is. And because it's a consumption-based type of service, you only pay for what you use. So when it scales up, you'll pay for that, and when it scales down, you're really only paying for the processing cycles. So it's a much more efficient model. So when we talk about iPaaS, we'll have a look here at the layers that are involved. So at the heart of it is LogicApps. And as Adam did in his keynote presentation, he talked a bit about LogicApps and how easy they are. They are actually incredibly powerful and when you talk about the concept of integration. So LogicApps can host workflows. So if you're used to using Windows Workflow Service, or maybe if you did BizTalk in the past with orchestration, this is what LogicApps does. It gives you the ability to orchestrate business logic, and it can do it quite powerfully. But not only does it include that ability for workflows, but it gives you the connectors to a whole lot of different SaaS systems, as well as other Azure services and Microsoft services. So LogicApps is really at the heart of being able to do iPaaS. Azure Functions gives you the ability to run code in the cloud. So if you have a bit of a complicated bit of a processing logic that you need to do, rather than trying to replicate that in a Logic App workflow, you can actually put that out into your Azure function, which you write in whatever language you're comfortable with, whether it be C# or Node.js, a couple of other languages that it supports. And you can call that from a Logic App. And again, it's completely serverless. So we'll have a look at that in more detail. Of course, messaging is at the heart of any kind of integration solution, and ServiceBus, which has been around for a long time, actually almost as long as Azure has been around, is a very, very robust messaging platform. So this gives you that brokered messaging capability, which allows you to have that loosely coupling between your services and application through topics and queues. We have EventGrid, which is for managing events, and that's extremely powerful. And I'll talk about the difference between messaging and events a little bit later in this presentation. So once you expose these services, you also need to protect them and have governance over them. And that's what API management gives you, is the ability to do that, and also a developer portal which allows them to be discovered and developed against. API management, as Adam said in his presentation, it's extremely powerful and extremely useful. It's not really all that cheap, but you get a lot of value out of it. If all you want to do, though, is say you have a bunch of different APIs hosted in different places, and you want to put a facade in front of it so that your users have friendlier URLs, function proxies is another alternative, a much cheaper alternative. It doesn't give you all the capabilities that API management does, but it does give you the ability to map URLs. Now, of course, with all of this, you need to have a development platform to work with. So Visual Studio is very useful. Being able, you can develop your functions in there. You can't create Logic Apps, but you can manage them, and you can manage the build and deployment of those with ARM templates, and I'll talk about that a bit later. And of course, Visual Studio Teams Services gives you that CI/CD pipeline that you need for your solution, so you have a mature model for that. And then finally, from the operationalization aspect, you need to be able to do your logging and auditing of it. So OMS gives you that capability along with log analytics, and LogicApps also has its own management OMS solution that helps a lot with that as well. So those are the main components of the iPaaS platform. So we'll start by looking at LogicApps. Now, Adam already took you through a bit of that and showed you how easy it is to develop, because it's got a very intuitive graphical user interface for creating these workflows. Every component of that workflow, which is called an action, is either a trigger or a connector or a workflow item. So every Logic app has to have a trigger. It has to have something that starts that up. And that trigger can be based on an event, and that event can be either pulling from another service, connecting to something like, say, ServiceBus or Event Hubs, or a tweet happens, or it can be a schedule type of thing, which is a recurrence trigger, and then it means it just happens, at an interval that you set it to. The other actions are either going to be a workflow action for doing processing logic, like conditions or statements or expressions, or they're going to be connectors out to those other services that you want to interact with your integration. And behind all that lovely graphical user interface is what's called the workflow definition language, which is essentially just JSON. So you can easily in Logic App go into the code view and work in that form if you prefer to. And sometimes there's subtle things or more complicated things that are just easier to do in the actual JSON rather than trying to get it to happen in the UI. So that is one of the differentiators between Logic Apps and Microsoft Flow, as Adam said, is that in Logic Apps it gives you that ability to get down into the actual code. So the workflows actually handle a number of sophisticated flow control mechanisms. So you've got conditions, in other words, if then else, you can do that. You can also do switch statements. You have looping capability, which is for each and do until. The thing to be aware of with the for each is by default, when you do a for each loop, it doesn't execute those actions sequentially. It actually, for efficiency, it will execute them in parallel. So a for each, if you give it an array of items, it will actually spin up a number of sub-processes that will process those items simultaneously. So if you don't realize that when you're programming and think about it, that can have some effects that you're not expecting. So there is actually a for each sequential setting that you can use, and that's when you actually you want it to process single-threaded, and you can tell it to do that. So you do have that option. But if you can be caught out with that if you're not aware. Every action, you have the ability to set a run after, and that gives you the ability to evaluate some previous action based on the status. Did that action succeed, or did it fail, or was it skipped, or is it some combination of that? So you can basically do some excellent exception handling based on that by having evaluation whether something before it succeeded or not. And also with the introduction of scopes allow you to group a number of actions together and wrap that in a scope, which then itself has a status. So you can then set your run after to look after the status of that scope. So that helps a lot with exception handling. So with all of this advanced flow control, you have the ability to do a number of sophisticated integration patterns. It has support for correlation. You can do sequential convoys and a number of other patterns. And then there's a few articles on the Mexia blog written by my colleagues that tell you how to do things like correlation. So I would suggest checking that out. The workflow definition language includes a number of built-in functions. So these functions can be used within expressions for when you're doing evaluations, for example, of conditional statements, or if you're doing some sort of manipulation of items that are within your workflow. And there's quite a bit there, and there's a link to the documentation on all of those. And I will be posting these slides up afterwards, so I'll send out a notification about where they are. So with these patterns, one of the things that we can do is a Viter pipeline. So how many have heard of Viter before? Have you heard of them? Okay. So Viter is validate, extract, transform, enrich, and route. So in the validate, for example, if you have a message coming in, you might want to do some XML validation on that to determine if the message is actually, if the data is actually valid for you to work on, and if the message matches what you think it should. So to do that, you're going to need an integration account to store a schema, and I'll talk about that on the next slide. Then you can do some extracts, so you can actually take maybe part of that message, the part that you're interested in, so you can do processing on that. You can then you can select literals or single nodes or node sets. You can do transformation, which gives you the ability to actually change from one message format to another, so you can actually translate from one schema to another. And if anybody's ever worked with BizTalk Server before, the transform action in LogicApps is compatible with BizTalk maps. So you can actually import your BizTalk maps and use them in your LogicApps. Enrich means that you can actually compose a new message, and you might be pulling in data from multiple sources, for example, and then combining it together in a message. And then finally, at the end of all that, you want to route that message somewhere. So the integration account is necessary if you're going to store schemas or maps that you want to reference in your Logic app, then you'll need a place to do that, and the integration account is what gives you that capability. It also supports B2B messaging, which LogicApps is very good at as well. So if you're ever doing anything with EDI, say for example X12 or EDIFACT, with or without AS2 support, an integration account can help with that, because you can store information about your trading partners and the agreements that you have with those partners. It does cost extra, and to be honest with you, it's not that cheap, but it is a very powerful capability. So if you really needed to do B2B messaging, this is an excellent platform for doing it, and B2B messaging in any service is not going to be cheap. So. Now, I mentioned before that one of the powerful aspects of LogicApps was the connectors. There are probably, at this point, over 200 connectors that are available to you. So I'm just going to start by looking at that big gray box on the right. These are all third-party SaaS applications and services that there are built-in connectors for. That's a pretty impressive list. I'm actually going to put a challenge out there. I've got a t-shirt here for the first person who can tell me a typical SaaS service you want to connect to that isn't in that list. Which one? Monica? Is that there? So, let's see, I don't think Monica is there, and it wouldn't be on the right side? No? Okay, open source, there you go. It's your t-shirt. Sorry? Yeah, I got to put it on the list. Yeah, and it is. It probably is on their backlog, I'm sure. Did somebody else raise their hand too? Which one? How do you spell it? Like ServiceNow equivalent. How do you spell it? Heat. Oh, Heat. Oh, H-A-T. Okay, Heat. It's interesting. Yeah. Okay. Fantastic. I don't know what size T-shirt you are. Would a medium do? Anyway, here you go. I'll give you that. Okay. So, but actually, you can see that there's still quite a lot of support, and there are several of these that are on the backlog. So they're coming out with new connectors all the time. In the last 12 months, they did 80 connectors alone. And they're also welcoming partners to go and help develop connectors for them too. So aside from the third-party connectors, you also have built-in connectors for Azure services. Those are the ones in pink. And the other Microsoft products as well, like SharePoint and Bing and Outlook and OneDrive and all of that. You also have support, of course, for all the common protocols like SFTP, SMTP, HTTP, SOAP, all of that's there. And you've got your EDI on the bottom, so you can support EDIFACT and Flatfile and X12. And then you've got these hybrid and enterprise connectors. And those ones are special, and I'll tell you why they're special in a moment. So Microsoft recognizes the fact that hybrid applications are really where all the power is. Fact is, you're always going to have line of business systems that need to sit on-prem. And it doesn't make sense to move those to the cloud, but you need to leverage the cloud in order to get your exposure and to get your global reach and to get your scalability. So the connectivity between your cloud services and your on-prem services is quite critical. And one of the things that gives that to you is the on-prem data gateway. Now that's a service that works with certain connectors in LogicApps that enables you to create that channel without having to make any changes to your network perimeter or your corporate firewall. So how many of you are familiar with ServiceBus relays? Wow, no one. That's amazing. Wow, maybe one or two? Okay, because that's been around for a long time. That's been a part of ServiceBus. So I wish I had a slide for it to explain how it works. ServiceBus relays work by actually installing an agent on-prem, and that opens an outbound channel to something, a secure channel out to the cloud, and puts an endpoint out there that your services can talk to, and therefore can receive messages coming in. As long as you have outbound connectivity through port 80 or port 443, you can have connectivity for services to actually send messages into your organization. I'm sure IT security people love that. It works only with specific connectors, and those connectors there are those special ones that I mentioned, the enterprise connectors. There's 14 of them, and you can see that they all sort of work with particular enterprise systems like SAP and BizTalk Server and SQL and all of that. So you have the ability to talk to your on-prem resources using that by configuring that on-prem data gateway. And there's some good news about that. The gateway, for one thing, it doesn't cost you anything extra to use that on-prem data gateway, other than maybe the data egress and stuff. It's just an add-on to one of those connectors. It's also good that recently they enabled support for high availability. So you can install that on-prem data gateway agent on multiple servers in your network, and that way you have that redundancy. That only came out recently. And it is very, very secure. It's using the ServiceBus relay, and everything is encrypted, and there's a secret required to access that endpoint. So it should satisfy your security requirements. And the other good thing about it is that it works over ExpressRoute too. So if you need to have that real high bandwidth and an isolated network and predictable performance, then you can use it over ExpressRoute. So moving on from LogicApps, we're going to talk about functions, which is the serverless compute option. So basically, this allows you to run code in the cloud without ever having to worry about where and how it's deployed. You just write the code. When you provision a function, you actually create a function app, and in that you add functions to it. And when you choose what your trigger is going to be for that function, so it's either going to be a webhook, or it's going to be a scheduled function, or it's going to be looking at some sort of event source like a database or something, or maybe EventGrid. Once you choose that, it actually gives you a boilerplate template for a function. It's a method with the parameters and everything you need, and you literally just write your code inside that template. And you can choose a number of languages. So right now I have it on another slide, but I think it has support for C#, Node.js, possibly F#. There's also some preview ones in there like PowerShell is in preview mode at the moment. And another good thing about that is that if you host a function in a VNet, then you can access your on-prem resources as well, as long as they're connected to that VNet. As I mentioned, functions are based on events, so the trigger can either be a schedule, or it can be connected to a data source, or it could just be a simple webhook. And then you write your code, so those are the languages that are supported. And then you have your outputs. You can also have multiple inputs. So only one input is going to be the trigger for it. There's one event, but you can also enrich by bringing in data from elsewhere. And it's very intuitive. When you configure these inputs and outputs, they're called bindings. They interrogate your Azure subscription and resource groups. So if you have, for example, you want to send something to table storage, you won't have to remember your connection string. The dropdown will actually have that resource listed in there for you, and you can just choose it. Some differences between the LogicApps and functions. So LogicApps, as we mentioned, they're meant for orchestrating their workflows and for connectivity, whereas functions are actually for executing discrete bits of code. So you can think of functions as being kind of like the microservices, and the LogicApps as being the orchestrator of those microservices. There's a graphical implementation for LogicApps, whereas functions is code-based. You have fantastic array of connectivity that's available to you in LogicApps. With functions, you have some connectivity to some of the Azure services, and of course then you can use webhooks as well. There is no VNet support right now for LogicApps, but you do have, of course, the on-prem data gateway if you need to talk to your on-prem services, whereas there is VNet support for functions. LogicApps are inherently stateful. That's something I didn't mention. They actually can be very long-running processes. There's persistence with those LogicApps, so it could, even if it takes days for a process to finish, LogicApp will persist that state for you. Functions, by default, is not stateful, it's stateless, but you can make it stateful with durable functions if you want to do that. And LogicApps can only run in Azure at the moment. There's no support for Azure Stack, but apparently functions can. So moving on to messaging, we're going to talk about Azure ServiceBus, which has actually been around for quite a while. So this gives you very powerful brokered messaging capability. So it basically gives you queuing and it gives you publish-subscribe patterns. It's important to realize that this is a push-pull model, so you may push a message to a topic or a queue, but whatever subscribes to that has to actually pull that message. That's important when we talk about the difference between ServiceBus and EventGrid, which is the next topic. There is a size limit on it. You don't want to go over a megabyte for those messages. If you did have to push a large amount of data, you should really use a claim check pattern. And that's simply a matter of you take whatever that object is, store it somewhere temporarily, like say blob storage, and you have a message that simply has a reference to where that storage is. Whatever picks up that message is then able to go and fetch and retrieve the actual data. It's much more efficient that way. So it's a very full-featured capability. It supports transactions, it supports sessions, it has dead letter queues, it supports deduplication, and a number of other great features with messaging. That makes it a lot more powerful than Azure Queues, which is, along with your Azure Tables and storage, you have that ability. Azure Queues doesn't give you all of those full features. So it's probably worth mentioning the difference between queues and topics. And there's a link which explains this in more depth, but a queue is essentially a first in, first out, a FIFO source, although you can't strictly guarantee that because it depends on the processing of the consumers that pick up those messages. But essentially the important thing is that when something's pulled off of a queue, only one consumer is actually going to get that message. You can have multiple consumers feeding from a queue, but they're competing. So each message will only go to one of them. The difference between that and topics is that when you create a topic with subscriptions, it's essentially a queue, but you can have multiple consumers for each message. A subscriber will subscribe to a message, and however many subscribers there are for that message type, they will all get a copy of the message. You can also use filters on those subscriptions, so you can say, I'm really only interested in messages with this property. This is where you get your publish-subscribe model. That's really so essential for a lot of integration patterns. So EventGrid is a relatively recent feature that came out, and that actually handles the concept of events. Now, the difference between a message and an event, it's a bit subtle. A message generally means that it carries data with it, whereas an event is really just a notification that something happened. So if we use the example of creating a file, if we had a message that represented that file creation, it would probably have some metadata to tell you where the file was created, when it was created, what its size is, and it will probably include the contents of that file as well. Whereas an event would just give you the metadata about it and say, hey, this file was created and here's some metadata about it, but not actually the data itself. It's a subtle difference, but it explains also why there's such a much smaller size limit on the messages that go through EventGrid. So EventGrid is a place where in Azure you can manage all your event handling in one central place, and it's actually wired into a lot of Azure services already, but it also has support for custom sources. Yes, I'll just show you what that means. So at the moment with EventGrid, it integrates with all of those services on the left that you see, so IoT Hub, Blob Storage, resource groups and subscriptions, Event Hubs, storage. So think about what that means in terms of resource groups and subscriptions. For example, Adam was talking this morning about people creating Cosmos database, to do their testing and then leaving them running, and suddenly he gets a big bill for it. So wouldn't it be great if somebody could get notified every time somebody created a Cosmos database? Well, you can do that with EventGrid because the creation of that is an event in a resource group or a subscription, and you can subscribe to that and then send notifications about it. So EventGrid is very powerful. So in addition to supporting that list of Azure services, both as publishers and as handlers, as subscribers, you'll notice that it supports custom topics as well. So that means that anything that can actually write an event in the correct format and send it to EventGrid can publish events. It doesn't have to be in Azure. So this is not limited to Azure. And also webhooks. Webhooks is just a URL to send the events to, so that also doesn't have to be in Azure. EventGrid is different from ServiceBus in that it is a push-push model. So you push an event onto EventGrid, and an EventGrid pushes that message to its subscription rather than the subscription having to pull for it. So it's like essentially like a fire hose of events going through. And it is extremely performant and resilient. So it's real-time capability, so it processes its message in microseconds, and extremely scalable. So it's built to handle 10 million events per second per region, which is a lot of telemetry. It's also very, very reliable, so it will try to deliver your events for up to a 24-hour period. At that point, it then drops it at the moment, but in the future, maybe we'll hope that there will be some kind of dead lettering that EventGrid will offer. With that retry, it does it at an exponential rate, and it also randomizes that exponential retries a little bit too, so you don't get the cluster of things happening at definite intervals. So once you build your solution with LogicApps or functions and you expose these endpoints, again, API management is where you have the ability to protect and govern and potentially even monetize your traffic to those endpoints. So this is what API management gives you. It's very, very powerful. It includes a number of security capabilities as well as access control capabilities. So the way this works, it's basically you have three different components to API management. So first you have the Azure portal, which is where you can actually publish your events. And as Adam said in his first presentation, that's actually eventually going to go away and be integrated into the normal Azure portal. But at the moment there's a publisher portal for APIM. That's where all your APIs are created and managed. You also have a developer portal which allows you to consume those APIs and discover them and actually test against them. But the real heart of it, of course, is the gateway itself, which acts as a mediator. For example, you can, if you have a custom resource, like you've created this API, and you can see from the URL, which is a little bit cut off, I don't know why. It kind of gives away where it's implemented, but you may not want to expose that to your clients. So when you create an API for that on the gateway, it has its own initial messaging format, which represents, again, API management, and you may not want to expose that either to your customers. So you can have a custom domain and make your URL look like that. So the good thing about this is that if you change anything about the implementation in the back or where that's hosted, while that URL can change, your front customer-facing one doesn't have to, because it can just remap and point to that. So it gives you that bit of a facade, as well as giving you all of the other advantages that API management offer you. So API management is based on policies. So policies basically execute code that can provide security for you, or features such as rate limiting or throttling, or maybe quotas. An example of using quotas might be you have tiered subscriptions to your services, so people who pay more can send more messages through at a time than people who pay less. That'd be something. To do that, of course, you have to be able to provide analysis of what's going on, and that's something else that API management does, is it provides you that monitoring and analysis. It also provides you caching and a host of other features as well. If you're, I think that you have to be at the premium level to use VNet support, is that right? So if you're using the premium version, you can then integrate API management with your VNet as well, which means that you can link it to your own backend services on-prem. It's not limited to just backend APIs in Azure. It can be anywhere. With your iPaaS solutions, of course, you have to be able to develop them, and there is Visual Studio support for all of this. So right now you can create and build functions in Visual Studio, and that's really handy because it means you can also write your unit tests and everything in there, and then you can build your deployment and of course integrate with your source control. LogicApps is a little bit different story. LogicApps, you can't create them in Visual Studio right now, but if you create them in the web portal, you can then bring them into Visual Studio and you can create ARM templates for it, so you can manage the source as ARM templates that way. And that's generally what you want to do anyway, because that enables you to redeploy those LogicApps in different environments and have that consistency with it. So there's a bit of work you have to do. You have to be careful with that you don't use ARM template expressions inside of LogicApp expressions. And there's an excellent blog post by my colleague Paco there, who talks about how you can prepare your LogicApps so that they work better in ARM templates and for CI/CD. And then, of course, to productionize your solutions, you want to add that kind of monitoring and management. So we recommend using OMS because it's extremely powerful for doing that collection of data and logging for you. And with the capabilities that the LogicApps management solution offers for you, you can actually create some fantastic dashboards to surface all of that information to you in a very consumable fashion. And you also have the capability, with a bit of work, to create some custom activity monitoring across all of your LogicApps as well. And there's a couple of fantastic blog posts there to tell you how to do that solution. So it's business activity monitoring, basically, in the cloud. So just to give you an idea how productive the team has been and how much they've been advancing, you can see all of the things that they've been working on in just the last 12 months. So the team has been quite busy in expanding the capabilities, and they're expanding all the time. So you can see there's been a lot of work done there. And in addition to all of that, over the last year, they've added 80 connectors. So that's increasing all the time. And every 2 weeks, I think it is, they have a webcast, a live webcast they do called LogicApps Live. So just look that up on the internet, and you can follow, and they give you an update on what they've been working on in that last sprint and what's coming. So they're doing fantastic work. And I'm happy to say, I should have said this at the beginning, just found out the other day that Gartner has placed Microsoft in the leading quadrant for iPaaS. Obviously their work has been recognized, and Microsoft has now become a very, very fierce competitor in that area. So these are a few things that they're currently working on right now. They've actually exposed their Trello board to show what's on their backlog and what they're working at. So that link there, the first of those 2 links, will actually take you to that Trello board. They're being very transparent about what they're doing. And these are some of the things that are on the list. Being able to have better failover support, have more designer improvements, better testability, and there's just some links for additional resources, and I will let you know when I publish these slides where you can access them. So that's my presentation for today. How did I do on time? That's pretty good, actually. Yeah, just about on time. Does anybody have any questions? Great. Well, thank you very much, everyone.